to the FUSiON-iO party on Tuesday evening, so hopefully you'll all be able to make it there as well. And we will have transportation to the LVCC following the event, so the ladies out front will be able to help direct anyone, but the buses will be basically at the main entrance. So I'm Shannon McPhee, Director of Communications at FUSiON-iO, and we're going to hear from Vincent Griesbois just for a few words of introduction about Fusion. Then the Waz is going to come on up and talk to us about his experience at HP and at FUSiON-iO, so we're really excited to hear from him. He does have to leave rather quickly after he speaks, so please feel free to take any photos you like while he's speaking. And then Vince will come back out and tell us a little bit more about Fusion, and then we'll hear from our great friends at the HP Workstation Group and Jeff Wood. So with that, I'd like to invite Vincent up.
It actually got me to join FUSiON-iO and do a bit more there. So I'm going to take a few minutes just to tell you a little bit about FUSiON-iO. In case you're not deeply familiar with FUSiON-iO, our products are already accelerating some of the largest data centers in the world. From Facebook to the New York Stock Exchange, that's all running on FUSiON-iO. And we are actually based in Salt Lake City, Utah, which might not sound as fancy as New York or London, but there actually have been some interesting developments out of Utah in the past. Anyone who goes to SIGGRAPH probably recognizes this little guy, but normally he's got little feet and comes from RenderMan. This is the Utah teapot. It's actually a mathematical model that represents everything you can run into in 3D. So this was developed at the University of Utah. We have two co-founders of our company, David Flynn and Rick White. David Flynn would be here today. Unfortunately, he's in China, quite busy. But we do have Rick White here somewhere, right over there in the back. Hi, Rick. And we're also really happy to be joined by our Chief Scientist, Steve Wozniak, here today, which he'll be talking to you in a few minutes. We've had quite an interesting growth over the last few years. You know, from the foundation of the company in 2006, notice also our partnership with HP in 2009. That's on the server side. So we've actually been working with HP Server Group since 2009. And today we're joined by the HP Workstation Group here, which we're really happy to have. So one of the new milestones that we're announcing here at the show is the new 1.6 terabyte IOFX. So 4 times the capacity of last year's 420 gig product. So this, obviously, with more capacity comes the ability to work with larger content. If you take a look at the screen on your right side over there, that's actually running 4K content. That's over half a terabyte of 4K uncompressed images playing back in real time off of the Z20 workstation.
Hewlett-Packard is very dear to my heart. Got a lot of experience with Hewlett-Packard. I worked there. It means a lot to me. Hewlett-Packard is like FUSiON-iO. They're both in my heart so deeply. So is a third company. Got to remember that. Now, Hewlett-Packard, yes. So I'm very glad that they're high precision engineering, workstations. I worked at Hewlett-Packard because when I was very young, oh my gosh, they made the most precision oscilloscopes and signal generators and all this electronic engineer stuff, So I loved the company. I always thought of them as real high-class engineering. And I was determined when I worked there, I want to be an engineer for life because I'm at the best engineering company. So out there, I saw the workstations in Fort Collins that Hewlett-Packard builds, and I was so impressed by the engineering. I mean, it really blows a lot of my concepts away. And I'm glad that they're joining up with FUSiON-iO, because our technology is the great technology. It makes all the applications of the world run faster, and it's really something to be very proud of here. Now, I've tried to have partnerships or offered things to Hewlett-Packard before, and I've been turned down. I have to be honest with you. Going back to the Apple II computer. A little humor doesn't hurt. I actually encountered this company. I was introduced by the founders, Rick White and David Flynn. And when they described how they were approaching the technology of using NAND flash to replace long-term storage, hard disks is what that means, they told me their approach, and it was very different than I would have even thought of myself, or almost any normal person would have thought of. Somebody would have said, let's take the existing technology, a disk drive, and make it out of chips in a way that it runs faster. That is the totally normal way to do things. What this company had done was said, let's take the chips, plug them straight into the computer, the server, the workstation, the whatever, the prosumer home device. Plug the chips right in there and write a driver that basically simulates a disk drive. And the advantage to that was I saw it instantly. I was actually kind of stunned. I didn't But then again, I saw that, oh my gosh, you've got all the advantages. You've stripped out a lot of the middlemen, cabling, RAID arrays, everything, and yet you get better performance anyway. You stripped the cost. You've simplified it, and that leads to greater reliability. And by plugging it right into a computer that has a processor, a brain, you can write software that makes it do even more things than you first conceived. Our first board that I was introduced to, the I/O drive, has actually been sped up 4 times without changing the board, 4 times just by rewriting the software on the host computer. This is a technique of innovation that I discovered at Apple Computer. Not just innovation, this was invention. If you look, FUSiON-iO was the first to say we should plug these chips into the server rather than put them on a cable just like a normal disk drive. I go back to times at Apple. What made personal computing happen is a thought that struck me this morning. It used to be that the input-output device was a slow mechanical teletype or a very expensive video display terminal in black and white that connected on a serial cable. It was a device on its own. The computer sent things to display and it displayed them. And it was very slow because of the interconnection from the computer to the device. It was also limited in what it could do. It could not do things like arcade games at Atari, that Atari was inventing, were doing. And so I sat there and this technology, okay, I said, let's make the video, let's make an NTSC, it works with your home television. That was the innovation because it's much less expensive. In the end, less expense is always good engineering, being efficient with money. And I said, let's make the video memory the computer memory, one and the same. The computer gets in, puts in a number, the video gets in and puts a green spot on your TV set. And then very easily, by changing things with numbers, that means digital world, you've got everything bouncing around on the screen. Sure, NTSC television, United States television, had never been presented in the books, in engineering schools, as being anything other than an analog art with all sorts of op-amps and differential calculus equations and the circuit analysis to make it work. How could you have a little digital circuit with a $1 chip putting out ones and zeros look like color on a TV set? Well, it just took crossing a lot of disciplines. Knowing how televisions were, color televisions interpreted color, knowing they would be faked out, and having a motivation wanting to do things. So sometimes when you have a new technology that presents better alternatives, you think, oh my gosh, I'll just put it out on a cable on a device of its own. I'll put my storage system out on a cable, in a big RAS array, and I'll have all the complications, all the slowdowns we were all used to that came with hard disks. The bottleneck to processors these days is storage. And FUSiON-iO's goal in life was, if we solve that bottleneck, we're going to make the processors so much more efficient, they're each worth many times what they are today. Another example was my own disk drive that I invented for Apple, the floppy disk. Plugged right into the computer. And that was kind of unheard of. Normally you put a cable out and you used a bunch of chips the floppy disk manufacturer gave you that obeyed disk language. And you had to have a chip in your machine that sent disk language. Thank God I didn't know a thing about disk drives ever in my life. I didn't know a thing about operating systems. I just sat down there and I knew that I would get to come to Las Vegas for the first time in my life. If I got this machine done in 2 weeks, Apple wasn't going to bring me to Las Vegas with them, but I said, if we have a floppy disk, can we show it? And if we show it, I had to come. It was a trip. I worked every day, Christmas Day, New Year's Day, and I just started out analyzing things, and I said, my gosh, why are all these chips out there on the disk drive doing work when I've got a processor I can write programs for so easily? It was in the day you could almost get a size of an EEPROM that had a program in large enough to run a disk drive. So I said, why don't I just put a few chips right here on the board, program it to run this disk drive? The result of that was, in later years, I was able to rewrite the software and add more data to the disk, improve its density, and speed up its access by making it go from track to track, not at a fixed rate, but accelerating, decelerating on each trip of the arm. And I couldn't have possibly done that if I stuck with the cable that went to a standard disk language. That's all I want to say for now. This is the sort of creativity and innovation that I saw in FUSiON-iO. I see it continuing. And like I said, they're the leaders, they were the first, and so many ideas and enhancements to the products, larger and larger storage sizes, lower and lower costs. It's been a wonderful thing to be associated with. right now, I'd like to conclude my remarks because I have to get to another event. I'd like to invite Jeff Wood to come up here. I want to shake his hand.
Frames per second. Has anyone seen here? Anyone here seen the Hobbit in high frame rate, 48 frames per second? Yeah, pretty much a large majority of you guys. So 48 frames per second means what? Double the frames. Again, doubling the data. So we went from this much data for a standard 2K movie that you used to see in theaters that you can still see today, to things like The Hobbit in 3D with 48 frames per second high frame rate, which is 24 times more data going through the pipe. And that's just 24 more times image data. There's also higher resolution models, right? Gollum has to be better modeled because he's so much clearer. He needs to have more detail. So it's a massive amount of data going through your pipeline. You know, with frame rates going from about 1 megabyte per frame up to 77 megabytes per frame, and needing 1.8 gigabytes per second just to be able to play back on compressed content, high-res content, that really becomes an issue when you're dealing with a workstation. So some of the challenges in production, well, the higher resolutions, obviously, that means a lot more data needs to go through your system, go through your entire development process. Also, workstation CPUs and GPUs have become massively powerful. In these Z20 workstations, we have 16 CPUs, 16 cores. And with hyper-threading, that's 32 threads. That's a lot of horsepower. That's a lot of capacity to work. But you need to feed those workers. And that's where the storage part comes in. As well as the GPUs. You have NVIDIA GPUs now with 3,000 CUDA cores in one GPU. You can have 6,000 cores processing data inside your workstation. So we have this unbalanced workstation where we're still using sort of antiquated storage systems to feed these massively powerful CPUs and GPUs. The other thing is the budgets and deadlines aren't getting any longer, or it's getting tighter, in fact, and there's so much more data that needs to go through the pipe. So we have growth with no end in sight, larger resolutions, larger capacities, everything's getting bigger. And we're using legacy solutions. We really kind of cater to three verticals. There's the enterprise world with the I/O Drive 2. This is what's running in a lot of servers for running databases, for instance. We also have the hyperscale, which we address with the I/O Scale product. And this is what clients like Facebook use, for instance. And then the workstation is the IOFX product, really destined for a single user that has very, very high requirements in bandwidth. So the IOFX 420 gig is the one we launched last year out there from HP, NVIDIA, Adobe, all of these different partners. You'll actually be able to see IOFX running at their booths at the show, at NAB. And even looking at some of the most advanced applications out there, like the Nuke from the Foundry, you can see that by adding an IOFX to your workstation, you get a significant performance increase. And this is even over SSDs, not just spinning disks. So really accelerating those applications for you. Now let's take a dive into how this technology works. How is it different from everything else? So the first key component is that we've created a memory tier, which is the IOFX here called IO memory, which is sort of our class of products. And it goes right inside the workstation, right on the PCIe bus. You can see it from the cards that are moving around the room here. And it shows up as 1.6 terabyte, almost 2 terabytes of memory speed right inside that workstation. And we're talking about getting an access time to the data that's in the microseconds. So it's actually 0.06 milliseconds to get data off this device. As opposed to network attached storage, where you have large amounts of data, that adds up very quickly. So even if we look at SSDs in a RAID, for instance, which would be kind of maybe the alternative, all of these little arrows are data transfers. That's what happens within the system. The application has to request the data has to go to a RAID controller, to a storage controller. All of these little arrows mean latency. It means access delay to get to the data. What we've done at FUSiON-iO is created a new memory tier, and we call this the cut-through architecture, where the application can directly address the data that's on the NAND cell. So we're cutting all the middlemen out, all of those antiquated storage protocols, which means an access delay that's much shorter, lower latency, and get that data to your application quicker. If we look at some application performance, the other part that's important is the consistency in the performance. So it's one thing to be able to peak and give you 1.6, 1.4 gigabytes per second here and there, but the ability to maintain that through heavy use of applications. With SSDs, you also often find areas where the application will actually be stopped, and it's waiting, and it's waiting for data. So even if your CPU says it's 100% used, sometimes it's just waiting. It's used while it's switching between different tasks, and it's looking for data. With FUSiON-iO and I/O memory, because we've cut all those storage protocols out of the way, we're able to sustain that data throughput. So get more work done, monitoring of what's happening in the device, how much read and write per second it is going through it, and even remote firmware update and format the device. So great for management in studios. The other component is a software developer kit. The software developer kit provides tools to software developers that allows them to tap into our device natively.
Understand what rich history we have from a workstation perspective. We've been in this market over 30 years, right? Back in the RISC Unix days, even back in the Motorola days when we were driving workstation products. But over that period of time, we have become the #1 provider of workstation products in the industry, very clearly over our competition. And many of the folks that were in the industry back then don't exist today, whether it's Sun, IBM, SGI, they lost the equation. And we kept on innovating and driving our products over that period of time. And as IDC reports, we have a very strong lead in the industry here. Now for us to be with Intel, NVIDIA, obviously from that perspective, but today we're announcing our relationship with FUSiON-iO. Now Hewlett-Packard has been a great partner with FUSiON-iO in our server group for several years, and you saw IOScale, some of the products that they have there, and we're the leading solution provider with FUSiON-iO in that arena. So we want to do the same thing from a workstation perspective because we really pride ourselves on the engineering prowess that we had. You heard Lawaz talk about that. In fact, he was in Fort Collins a few weeks ago where he got to visit our labs and understand exactly what kind of performance, innovation, and reliability that we drive in our workstation products. And he was very excited because it brought him back to his roots with HP and reminded him of the engineering work that he did way back when. Now, if you think about it, since we've been in the workstation business about 30 years, that's about the time frame was at HP. So a very exciting tie-in from that perspective. But for us, it's and drive that fantastic performance that Vince was talking about. Now, how many of you remember way back in the day, maybe you're as young as I am, right? Terabytes. And soon we'll be talking about petabytes, right? From a flash NAND perspective. Incredible, right? It's amazing. And the performance that this is going to provide for us, you know, it won't be long. It's going to be in our lifetime, obviously, in the next many years, where you won't see a spindle-based hard drive, right? I'm convinced, right? From that perspective. So for us, you know, on the workstation side, what really caught me about FUSiON-iO, I was very skeptical about this classic card, putting it integrated into a workstation product, until Rick and his friends came to Fort Collins and talked to us about, you know, it's not just about media and entertainment. It's about those guys who have large data sets. And the bottleneck in the system is the storage.
4 times the price. But we will be announcing that, the pricing with availability this summer.
Certified for anything other than HP?
It is available through a few resellers. In terms of certified, that's very different.
I mean, will it work on any other computer?
It does, yes. Yes, it's a standard PCIe connection. With HP, what we're doing is really going through the gauntlet, you know, testing it to a level that no one else does, to make sure that it's properly integrated and everything runs at optimum performance.
Here.
Great presentation. Is the performance enhancement acceleration transparent to users of Avid, AutoCAD, or special drivers needed, or it just happens?
It is. So there are some configurations. Obviously, if you, like, for instance, we were running on this system here, we have SpeedGrade from Adobe. The default is 0 to 6 threads. With our product in there, we changed the configuration so it runs naturally, but we actually had it running at almost 80 frames per second, I believe, earlier. So, you know, the ability to run 4K very, very, very quickly. So it is transparent, yeah, to most applications. But then you can also leverage the software developer kit and really squeeze every last bit of performance out of it.
Is this set up as storage or workspace? When you turn the system off, do you lose all the data?
You don't lose any of it. It is persistent. So the device uses NAND flash just like an SSD, but that's the only comparative. It's the same kind of base medium. the data connection path is completely different to the data. But it does use NAND flash, so you can shut the device off. In fact, I'll take mine out of my workstation, I'll put it in a Thunderbolt box and travel with it on a laptop and still get 860 megabytes per second while I'm traveling. And then get back to the office, pull up.
Shortly, I think we were planning for 10:15, but got done faster. But if you do have questions for Vince or Jeff, please do feel free to come on up. And again, we thank you all for coming and have a great NAB. Thank you.